Well, thank you very much for inviting me to this course. It's a pleasure to be back in Woods Hole after quite a long time. And having this beautiful weather, I mean, it's just nice. Too nice to stay here, probably. Do we have a pointer? So it's not so important.
Is there one up there? Yes. Little button right there.
So the objective of these 1.5 hours that we have is to... No, I haven't. To look at publicly available large data sets that are relevant for ocean acidification research, CLODAP and CARINA, and use a software to analyze these and visualize the data. So in a way, we want to ask ocean acidification science questions, looking at high-quality global ocean data sets. So I briefly listed what I hope that you will learn. Well, the first one, be aware there are these existing large data sets. You can benefit from them. They are publicly available, doesn't cost anything. They contain the work of lots of people, hard work, as you now feel better on what it means to make good measurements, I think, after the course, after having been in the lab. So that's easy. Then, as Heather has said, I'm trying to give a crash course in Ocean Data View. We have little time. We can touch it. I will only do what's essential to do the examples that we want to do. But I hope, ultimately, that you see there is more. And if you like it so far, and you get interested, then why not keep on going, trying the software out? It can do much more than you will see today. One important aspect will be a calculation of derived carbon parameters, as you already have done last week using CO2sys, I think, the software, and also CCarb, that allows you to calculate many, many parameters. Similarly, Ocean Data View also allows you to calculate these things. And we will go through it with the objective then to display these derived variables just in the way as if they were measured directly. And the other thing which I'm not so sure about, it depends on whether people have actually the need and have brought their own data sets. We could add this. Did people bring their own data set and have an interest of getting it in? So we should try to have at least, let's say, 15 minutes at the end to do this. But the important thing I want to tell you, we are doing it today on pre-created data sets that I have built based on data that I was given. But of course, adding data, and especially your own data, that's part of fun here. So that's always possible. I think on Wednesday, Bob Key in the morning will give you a much more detailed overview of the 2 data sets that we will talk about. But just briefly, to give you an indication of what kind of coverage we are talking about. This CLODAP data set has top to bottom data for more than 12,000 stations, 360,000 samples. Can you imagine doing all these kind of things that often? And even these very important parameters that we will look at, alkalinity and total carbon in the ocean, they exist for roughly 1/3 of the samples. So we have lots of material to work with. CARINA, that's actually the newer of the 2 data sets, just came out. It has a strong emphasis on the North Atlantic, Nordic Seas, and Arctic Ocean. CLODAP did not have any data in the Arctic. So if you are working in the Arctic, this data set, CARINA, is the one to use. We will look at both. It has a similar magnitude, lots of stations, and again, we have lots of carbon data to play with. Okay, while I'm speaking, why don't you start up your computer if you haven't already done it? And I'm kind of assuming that all of you have installed the software and also have downloaded the data. I'm afraid if you haven't, we don't have time to do the installation now. What I also, before I go into it, what I would like to see is who has never used ODV, so that I have a feeling. Okay, so we will start basic. What we will do, just to give you an overview, at the beginning, from now on, most of the time we will work with the program. But this first part, which I called guided exercises, I will be kind of showing where the mouse has to go, which kind of clicks have to be done, and so on. This is kind of a guided, and at the beginning it's just telling you the fundamental concepts and how to operate it in general terms. But then also we will learn by actually doing something practical already. So we will try to do sections. We will try to calculate some of these parameters, produce sections of these calculated parameters. In this case, I have arbitrarily chosen some. If you have special wishes, I'm responsive. If you don't want to see PCO2 but want to see something else, that's easily done. Just let me know. But then also, within the guided exercises, we will go through how to make maps of certain properties on certain surfaces. And I'm hoping that up to here, we have spent less than an hour, hopefully. So the remaining exercises, I would like to hand over to you, and you should try yourself. If you get stuck, you raise your hand, and I will try to sort things out. I can already tell that by the time we reach here, I will have forgotten to tell you some important things about the software. Without, you cannot solve these. But when we sense that lack, I will add this additional information. So I hope everybody feels ready that we now go into the practical part. That's the main thing. We want to practice. I can tell you for hours, but at the end, when you leave the room, hopefully I have gotten you interested and you have a feeling on how this software ticks. And people who are motivated and interested, they will find out the other issues themselves. So that's the kind of hope that I have. Okay, when you have installed the software, at least on Windows, so I see we have several Mac people. Have Mac people found out how to start the software? Who has not? Let's ask this. On the Mac, you go, in English, it's called programs, applications, it's called applications, and then ODV. And then it should be visible. Is that how it works on the Mac? Do we have Linux people here?
You have to go into bin Mac. It's in the bin file.
So people on the Macintosh, if they are unable to start the program within the next 5 minutes, please raise your hand, because that's the step we definitely have to make. Sort of. Windows people should have this icon on the screen, right? Everybody has it? Please, whenever I'm asking something and you have a negative, you don't see it, you're negative, then please raise your hand. If I don't see hands, let me assume everything goes smoothly. So we double-click on this icon. And then you should see this screen. Any negative? What about the Macintosh people? Doing well?
I have this include directory, temporary directory, computer name, username. What was that about?
Click OK. So from this state, if we really want to work with data sets, you go through, I would say, the normal route, File, New. Later, once you want to come back to what you have done probably this afternoon, you would go, and you want to open the same files as you did now, you would go through recent files, and the ones that you have used here should be listed, and you just choose one of them. But if this is the first time you do it, then File, New, File, what did I do? File, Open, File, Open. And then we navigate to wherever you have stored the CLODAP database. Would you remember where on your disk you have the CLODAP database? I hope, did you unpack? They came as zip file. The first thing is we have to unpack the zip file. For those of you who have, and once you have navigated for the CLODAP, it's CLODAP version 1.1 bottle. If you go inside, one of the files has this icon. That's the one we want to open. Okay, I have done it. How are we doing? We take our time with getting everybody on board because it's meaningless if I continue fast at the beginning.
Without the icon, what's the extension?
VAR.VAR.
Global bottom? This is what I get.
That's fine. Oh, you opened the other one.
Yeah, that's
Karina.
no, it's global. That's global.
It's CLODAP. Okay, never mind. Do we have negatives? Yes?
At least we have the same thing.
That's fine. That's fine. You don't have to have it exactly the same image. Let us just open. Bottle, CLODAP bottle. There is no? Let me go around and look at your screens. Do you need help?
I know. I've done on the Karina, but not
On CLODAP? Oh, it's. Do you have it on your disk?
No, I'm doing it now.
Oh, you don't have it.
Yeah.
For those people who only downloaded one of the data files, just open the one that you have. At the beginning, we just want to describe the philosophy and how you basically operate this. Also, don't be surprised if you don't have exactly the same screen. We want the software open, and so something. So my feeling is that maybe 90% of the people we are now having on board. Then let me continue. Just to describe the application window of the software. There are several, and I'm now maximizing it here on the screen so that we just look at this one. The main area, this area here, with the white paper background, that's what ODV calls the canvas. That's the area where we will plot onto. On this area, we can have a map. A map will always be there. You can't kill it. You can't delete it, nothing. You can make it smaller. You can do many things with it, but there will always be a map showing the stations that are in this database. And on the remaining area, you can have one or more data plots, as some of you already have, and we will have in a minute. It's very important to notice that the mouse, when you move it, always knows where it is. Watch this area down here. So it has realized it's over the canvas, has some coordinates. Now I'm moving into the map, and it knows where it is. It also knows when you move over to these windows, which we will explain in a minute. The mouse is essential. So if you don't have an external mouse and you are not so flexible with your mouse pad, that makes life a little bit harder. The mouse is important. We move the mouse constantly, we click the mouse constantly. And there are two kinds of clicks, and let's start with the first one. So let's put the mouse over the map, close to a station that we are interested in, and click. Left click, I should say. Left mouse click. You should notice that this station, which we now have clicked on, has a mark. It has a red cross. And the information about this station, well, the experts call this the metadata. Okay?
How do we get the big map up on the screen? I have some kind of vector profiles.
Okay, let's. Okay, I'm skipping ahead, but why not? Mouse over the white area, canvas, right click, and then layout templates, full screen map. What I can tell you, and that will constantly happen, there are many, many menus with many, many options. Some of them have shortcut keys, so I could have told you just to press F8 in this case. But so in my case, I already had a full screen map.
So now I have a map where it's
Okay, we come to that. Don't worry if your map is not exactly the same. That's part of the business. At the end, when you walk out this room, you should know how to make it just like here. Yes?
Does it matter if I don't have the station ID sample one?
No. These are examples. I try to tell you general terms. So if
She doesn't have the sidebar on it, right? That all of that, none of that information is present in any form.
ooh, I have to come soon. Don't have it. Oh, you are using the old ODV. Everybody was supposed to install ODV version 4. That's the old version. Sorry. Listen carefully and watch your neighbor and what we're doing. Okay, the point I want to make is left click selects things. So if you left click into the map, it will select the station, this one. That will be what ODV calls the current station. The focus is now on the data of this station. Here is information about the station, metadata as the people call it. So we would learn it's cruise 15, it's station with the label 14,055. It's a bottle station. This is the position. This is the date when it was taken. CloudApp, unfortunately, doesn't provide the daytime. If it had, we would also know when during the day. Here, in this second window, we see the data of one of the samples of this station. Typically, if you ever have been on a ship, on a cruise, you take a station and you have lots of samples. In this case, this station has 36, and here we are now looking at sample 1 out of these 36. If you want to step through the samples, you could use the arrow keys up and down. So I'm now hitting the down key once. And from sample 1, we have moved to sample 2, and so on. So in principle, by using the arrow keys, you can actually read all the values from any of these samples. This last window we get at later. Okay. Left-clicking selects something. Right-clicking, as we already have done, brings up menus. It gives you choices of what you can do. And notice, the menu that comes up depends on where you right-click on. So if you right-click on the white area on the canvas, you get options that are kind of applied to the entire page. Like choosing the layout of the windows. If you right-click on the map, you get a different menu. And those are options that will be applied to the map. The general rule is, if you want to do something to an object, like the map, or later you will see data windows, if you want to do something to them, right-click on them. So it's important to move the mouse. Always move it to where you want to do something, and then do it. Most pages, most windows, the map and also the data windows that you will see soon, they have the possibility to change the properties. And why not do it now, because we already had a request. Oh, first of all, before we go to properties, if you don't have a global map, just like here, but you want one, then you would choose this option here. If you have applied it, you should have a global map. Is that the case or not? Okay, so let's change the properties. So how do we get there? Right-click on the map. We want to change the properties of the map. So right-click on the map and then...
On the Mac, how did you get to the global?
The right...
Control thing, okay. I only had a Mac for 2 weeks.
Do you get it?
I got it.
Okay, map properties. It's working? We can't go through all of these possibilities, but some. Let's do it. So one obvious thing is changing the color of the dots that are marked here, or changing the size of them. That would be done under display style. So now I have a blue as a single color. I go back to properties. Sometimes people want a different projection. So you go to that page, projection, and you choose one of the available ones. And if by hand you want to, now you don't want a global map, but maybe you just want a part of a specific domain that you are interested in, you could specify north, south, latitudes, west, east, longitudes, just to zoom in. But right now, we don't do it. And I just come back. One thing maybe I should have said right at the beginning. Here on this screen, the area of my canvas is kind of too large to fit into this rectangle here that is available. And one would have to move to see the obscured part. Sometimes this is not desirable. Let us change this. There are general settings under View, Settings. Again, there are many things like setting fonts and different things. But what we want to do is use Canvas. Do I still have people on board? Under View, let's do it again. View, Settings. On the Mac? You don't have it? Impossible. On the Mac. The Mac specialists have the preferences under where on the Mac you typically find the preferences of the program. That's where they are. Under ODV4 and then preferences, I think. Do you find it there? Settings. People are on board again? Any left out people? No? So then, settings. Canvas, fit to screen. And then, OK. Now, the white paper, our canvas, is just made as large as would fit here. So we don't have to scroll all the time to see other things. That's quite useful. OK, let's come back to the map. Now, let's zoom into specific areas. Any preferred area you would like to look in? Woods Hole or... So we want to change something in the map. Right-click on the map. Choose Zoom, this option here. Okay. When you do it, you should have noticed there is now a red rectangle around the map. That's kind of the zoom handles that you can move. So go over one of them, for instance, here in this upper left area. Press the left button, hold it down, and then move. Okay? And let it go off when you're done. If we want to move this new smaller rectangle, put the mouse in the middle, notice the cursor is now cross. Again, left mouse button down, move. Now the whole thing moves. That's the kind of principle that comes again and again when we zoom into or out of a window or some other things. So it's always getting close to the active areas, the lines and these pins. Left mouse button down, moving. And then when that's the area you are interested in, you hit enter, and we are now just looking at this area. What I should also say, sometimes you are doing something and you immediately regret that you did it. Maybe you had it already. Then there is undo. Okay, undo. We want to undo the whole canvas part. So right-click on the canvas, say undo, and as you can see here, it keeps a record of changes that have been done. You can actually go right back and discard all the changes if you like. But if we just want to undo the zooming, I would do this. And you are back. Okay, what else? Now, let's do some data, I guess. I mean, with the map, let's assume we are finished. There are many more things, but for us, it's sufficient. Now, let's get some room for data plots. Yeah. And we do this. Now, we want to change out the layout of the page, basically. Ultimately, we want a smaller map so that we have room for some data plots. So we have to change the page layout, right-click on the canvas. And then there are several ways we will do the easy one now. There are several layouts which I provide as template layouts. And that's good enough for now. And there are many. This one you have already seen. If you just want to have a map, you would use a full screen map. But now we want to prepare for having sections. So let us choose a template that allows us to have some section windows. So let me choose this one, 3 section windows. There will be one large one and 2 smaller ones. You would have to explore what kind of layout you get using these different ones. But of course, if you choose 6 section windows, you can anticipate they will be small. They have to fit on the screen. So for different purposes, you choose what you need. But let me choose just this one. And now we have a situation where, and anybody lagging behind? Are you with me?
Is it possible that that's a Vista thing? Because I can't get any of your colors or any of the layers on any of the maps. Work with Vista, if that's possible?
Well, it does. I would have to get back to you separately.
We found something like that. It's sections, different sections.
Okay, some people already see some sections on the screen. Don't worry. Oh. Well, no, I say it in 10 minutes. Even those who already see some sections, don't worry, we will replace the ones that you have now with what we deliberately do now. Okay? So in order to display the data of a section, the map first has to contain a section. A section is something that belongs to the map. So you can imagine we will have to right-click on the map if we want to define a section or if we want to change an existing one. So right-click on the map, and then here in the lower part of the menu, we have this option, Manage Section. And it has a sub-menu. And what we want to do is to define a section. I want you to define your first ODV section. So everybody's here. I will now click this. Yes? And what should happen on your computer is that now, temporarily, the map will use the entire screen. You should now see that the mouse cursor has changed. It's now a crosshair cursor. Whenever Ocean Data View has a crosshair cursor, it expects that you click some points to it. And what we now want to do is to click a point at the beginning of a section and then continue to click some along the way of the section. So let me, do you have a favorite section? I would choose this one here, coming from Newfoundland and then making a bend here and then continuing to Europe. Okay, but you can choose any other. So you go to the beginning and somewhat beyond the beginning so that we have some extra space at both the beginning and the end. So here. And you left click to enter the first point. Once you have entered the first point and you move the mouse, the first point stays fixed and you will have a line to your current mouse cursor. Okay? Do you get this? Anybody having problem with that? Then the rest is easy. We continue clicking. So here I put some additional point in the middle. Definitely I click on the point where the direction changes. Then I'm following the section with some few points. Imagine you misclicked. Let me misclick. Then this one you want to remove. Go close to it, right mouse button. It's gone. Come back down. This point, this point, this point. So would people be able to follow this section clicking? I mean, you see in this case that we have a section around this rather easy cruise track. You could do sections, quite complicated ones. Actually, if you really had a scientific reason, you could also come back to your beginning if you liked. So it's very flexible. Actually, there's no cruise track that ships can go which you could not have as a section here. Okay? So are we at this point? Then press enter. And let me see how many people press enter now. Everybody's pressing enter just to please me. Do you get this dialogue? Who is not getting it? Need help? Anybody needs help? There are just a few things that some properties to this section that we have to add. And let me move this dialog away so that I can see the section. Do notice that now the points that I have clicked have been replaced by a band. And sections in ODV are bands with a given width that follow the track that we have just clicked. Now, sometimes you want a narrow band, sometimes you want a wide band. This property can be set down here. So if I wanted this to be a narrower section, I would put like 50 kilometers. Oops. And notice it's visually following. What you put in is displayed here. Definitely, you could say here, my section that I have now defined is too narrow. It would not include the points down here. Always adjust these settings so that the stations that you want to be part of this section are inside the band. So I will increase it again just to make sure that those other stations belong to the section. So the width is something important. The other thing is, what should we use as coordinate along the section? Remember, the section had a starting point where we started. That's actually indicated if you have sharp eyes by a small red star, so you always know where you actually started. And then we follow the track that we have just clicked. And for this, what ODV calls the section coordinate, what coordinate are we using along the section? There are three choices. Distance, that always works. That's distance from the start in kilometers. If you make a round circle around something, that's actually the only coordinate that's meaningful. But in our case, where we have more or less a zonal section, choosing longitude as the section coordinate makes sense. So let us, in this case, choose longitude. If we had a meridional section, we definitely would consider choosing latitude as the coordinate. That's basically all. There are some more things that have to do with bottom bathymetry, but I leave this for your exploratory phase. We are ready to press OK. Who's not with me?
The section coordinate, so what is it? It just takes the mean longitude value?
Well, you will see immediately. When the data, for instance, this station are plotted in a section, if you take distance, it will be the distance following the path from the start in kilometers. If you take longitude, it will take the longitude of that station to place it. So that is quite important here, and that determines how your plot will look like. And you can try different settings later. Here, what makes sense is longitude. Ready to press OK? Yeah?
If you decide to try to put down all the dots in a certain region, and then you have a line that's crossing and
Say again the beginning.
if you're trying to collect all the dots in a region, all the samples in a region, and your line is crossing itself and zigzagging all around, does that matter? Does the order in which you place the dots matter?
I suspect what you want to do can be done differently from using sections, and we may have time to come to it. If it's ever necessary that you have to click an erratic path, then that's not the way to do it. Sections should follow cruise tracks. That's where they are supposed to be used for. But sometimes you could choose a section that not a single ship did, but is your own combination of what you want to do. Okay, I click OK. Now, the section has been set up. The windows come up, but so far, no data. I mean, rather boring what we have here. The reason in this case is that what we are plotting is kind of boring, sample numbers, and down here we have sample numbers on the x-axis, cast number on the x-axis here. So it's just using the variables in the collection. The first one is depth, the second one sample number, then cast number as default for these windows. In many cases, when people have as the second one temperature and the third one salinity and so on, that's meaningful. In this case, it's kind of boring. So we explicitly have to define what do we put into these windows. And so we want to change the window. Let's start with the large one. Do all people have large section windows? Right-click on it. And then go down where it says X variable. And in section plots, what you always want to put is section longitude. Because on the x-axis, we want to follow the section. And section longitude has just been created when we have defined the section. So it's at the end of the list. So you choose this one.
Does section longitude coordinate with whatever you said the coordinate variable was?
If you had chosen distance, it would say section distance. If it was latitude, it would say section latitude. But that's the important thing to put on the x-axis. We want to follow station by station on the x-axis. So you put that on here. Still, we have not much to see. Now, what ODV calls the Z variable, that's the one that will bring the interest here. So we wanted to have DIC, total carbon. So let's put total carbon onto Z. How do we do it? Right-click on it. Now we go down to Z. Notice again, for these things that happen often, to put variables on X, Y, Z, there are shortcuts. I could have just pressed X to define the X variable, or just press Z to define the Z variable. So Z variable. Am I working in the cloud, or are people still with me? Who's not? That's the most dangerous too. So that ultimately I'm working on my own. And people, the light is getting dimmer and dimmer, and people are walking silently out. I try to avoid that. So please give feedback. Z variable, total carbon. In the CLODAP database, it's denoted by this cryptic sign here. So we choose it and say OK. And we still don't have nice things. Whenever that happens, there is time to adjust the ranges of the window. right-click on it, say full range. Again, this is something that happens often. Control F will do it. And for the first time now we see a section. And this is the default style on when you set up a window and you request X, Y, Z display of data in a window, you get what I call honest display. Honest means that wherever here along the track, notice these are the longitudes here. Wherever you have a station and wherever you have a sample versus depth, there will be a dot. And when we actually have, well, like for instance these black ones, that tells us at this longitude, at this depth, there was a sample taken. Unfortunately, it didn't contain total carbon. So you would have an indication there was a sample, but they just didn't measure this one. But fortunately, there are some of the samples that have values for this one, and they are colored here. And the color to value translation, that's indicated by these color bars. So you would see that the orange values like this one, they belong to values around 2150 or so. The greenish ones, they are on this kind of horizon. Okay? Honest, I would encourage that before you do anything else, like what we will go on doing now, that you look at the honest map, because that immediately tells you what kind of data coverage you have. It immediately tells you that you have quite big holes in certain areas. It's honest, but probably not publishable, this one. But still, for data analysis, I urge you to start with this kind of display. If you find that the points are too small, we can change that. That's part of the properties. Right-click on the window, Properties, Display Style. We just increase the size of the dots. And then they become larger. You can imagine if you increase them to huge size, then you have a continuous map. But it doesn't look good. Don't try it. One thing is important. With the map, we zoomed. In a data window like this one, you can also zoom. Right-click on the window, zoom. And similar to the map, you get this red frame, and you can manipulate as you want it. Don't do it right now. If you want to abort something, press Escape or the right mouse button. But one thing we want to do is it seems like in this specific example, the range of this color bar is well beyond what we have here. And wouldn't it be nice to not waste these colors which are not used? That's called Z zooming. Remember, that's the Z variable, that's the color bar that goes with this Z variable, Z zooming. And it's a property of this window, so right-click on this window, Z zoom. Who is not following? Anybody? So when you have been successful, you should see now a similar red frame around the color bar. This time, only the bottom and the top can be moved. Not the sides, doesn't make sense. But if we want to bring the color range to the colors that are actually needed for this plot, we would bring this one up to the greenish colors here, like here. And maybe the top a little bit down, like this. The principle is the same. Move to these pins, left button down, keep it down, move the mouse up and down. And then release it. If this is what we want, I press enter. And then see, now we are having a section that really goes from reddish to magenta. So it much better, this color bar much better represents the range that we have.
Is there a way to adjust that those limits numerically?
Yeah.
Okay, so that you can get exactly the limits you want.
Yeah, let's do it now. In addition to zooming into X, Y, or as we have just done, Z, you can set numeric values for all these three axes. Again, it's a property of this window, so you right-click on this window and you say Set Ranges. Then you will have fields and you can specify precisely the values that you want. Okay. I don't do it here. So I would say that's kind of a good, honest display of total carbon from Newfoundland to Europe. And the experts can make a story out of it.
One way we can, the last action we did, set range.
Oh, set, how to do it? So you right-click on the window and then set ranges. Full ranges would go to full ranges, but imagine if there's one outlier taking you way off, that will can cause a quite inconvenient range. So I think now is the point where we have invested enough clicking and time to find something nice that we learn how we can save what I call a view. A view is kind of the setup of windows, the domains in the map, the selection criteria, which we haven't done yet, the whole kind of configuration.
What would happen if you set the range? What would happen to an outlier? If you set your concentration range?
Full range?
No. Suppose you set it the way you did and there was one of those points in the middle was an outlier.
Well, if it's an outlier to the low values, it would use this the color in the triangle, which is a very light magenta. And here, honestly, it would be hard to distinguish from the next color here. But that's a matter of the color bars. And we don't cover this today, but color bars can be adjusted. So definitely, we want to save the whole setup. Because imagine we have to go for coffee break and shut down for today, and you have to take the computer off. Tomorrow morning, you don't want to redo all this. So we want to save what I call the view, the kind of overall setup on how we are looking at the data now. Don't forget, we are still having the CLODAP data, which is global, but we have chosen just to look at the North Atlantic. Actually, we have defined a section, and all the data that we are seeing is just the ones that fit into this band. We are not seeing any other data right now. So all this I call a view, and that can be saved. So you right-click on the canvas, and you go down to Save View As. And then, depending on Mac or Windows, you get the typical dialog. You go to the directory where you want this, and please specify a real good name for it. Because maybe tomorrow, or by the time next year, you will have saved maybe 50 views, and from the name, you want to tell what it will give you. So here I would say that's the total carbon section, blah, 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 to have a good name. And then you say save. So next time you can load it tomorrow morning by right-clicking on the canvas and say load view. Well, I didn't save. Oh. Well, believe me, load view and then come back. What I also should say, ODV, when you shut it down, it remembers the last collection that was open and the name of the last view. So when it comes up, it will open the last view, which obviously for the different people was a different one. So not everybody at the beginning saw the same thing, but there's no magic.
It's saving as a picture, as an image?
No. That's don't worry about the format. You don't have to look at these files. This is some. It's a file.
Save the canvas as image.
No.
Okay. So
Just give a descriptive name. Don't worry about how this is technically done. Okay. So what we want to do, make a nicer plot now. And are you ready for the next step? So we go away from honesty and we put our hands into the mathematical dirt. No, honestly. And again, if we want to do it with this window, you right-click on this window, and it's part of the properties. Display style, that's the page. Remember, we were working here original data, and previously I had changed the size and these kind of things. But now we want to change it to gridded field, which will make us a continuous field. But remember, there's mathematical magic. We have to fill in the holes. So there are computations behind it. And if you don't trust these computations, you will not trust the image. I just always say this as a warning. But let's do it. There are a few parameters which we don't have time to get into, which control the way this so-called gridding is done. Basically, these are scales that determine over how large areas the averaging is done. If these values are chosen much larger than they are now, you will get a very smooth field, possibly wiping out important signals in the data. If you make it too small, you may not be able to fill the holes entirely. So there is subjectivity in here, and be warned, gridding is something potentially dangerous. Yes?
What are the units of those length scales there?
They are in per mil of the axis length. It's something you don't want to go into in our speedy session. So 20 would mean 2% is the 2% of the x and 2% of the y range. Here you can read in y we are going from 0 to 5,000. 2% is 10 meters or 100 meters. That will be the typical range over which the averaging is done. That's too much for today. And I do it, and it will fill. And with these kind of averaging length scales, it was unable to fill the larger ones. I could increase them and have a better representation. What I also should say is, on this properties page again, there's a choice of methods for the gridding. The standard one is what I call VG gridding. This is a kind of a fast and dirty method, the one you have seen here. If you want to make your graph for the publication and you have a little bit more time available to do it, then choose Diva gridding. The Mac? Well, if you have installed the latest version, you should have it automatically. In the past, this Diva option was optional, so you had to install some extra thing. With the newest versions, it's part of the game. Let's just quickly do it so that you have an impression. It takes much longer to do, but there is much more expertise behind it, and you get this one. Before you publish your Nature or Science paper, use Diva gridding. That's what I'm saying. But it takes too long to try many things out in a minute. Okay, now we have spent 1 hour. One thing we definitely have to do. Are there questions up to this part? Am I overwhelming? Are people totally off? It crashed? Don't tell anybody. Well, I would have to have a deeper look. Any more crashes? Not too bad. Well, I should say, I mean, we try to make it free of bugs, but that's impossible, and occasionally it does crash. But I should also say, we as a developer group at RV, we try to be responsive. If you send us a nice email, don't tell us it's a terrible software and you hate us. But if you write us a cooperative email with enough information so that we can reproduce the error, that's important. Usually we ask you to send us your data set as well. Once we can reproduce an error, it's a matter of then it's easy to fix it. We try to be responsive. Any other questions at this point? Oh, here. Well, we have chosen a layout with 3 section windows, but so far I had only time to fill this one. But here, let's quickly do it. Let's here do on the x-axis alkalinity, on the y-axis phosphate. I don't know whether that makes sense. And full range. And because we have not put a z variable, it will be a unicolor plot. You can actually define the color to be used. It doesn't have to be black. It can be anything. But it just would be the data that belong to those stations inside the section band, alkalinity versus phosphate. And again, I don't know whether that's reasonable. In the same way, you could fill any other plots. Okay? So one thing we have to do, how do we calculate these additional carbon parameters? This is what we need to do. And I should say, in addition to what people measure, this kind of list, the software can calculate lots of additional parameters. How do we get them? Well, it seems to have to do with the list of variables. So put the mouse over this window, right-click, and you get a menu. And the second option, that is the one we want to do. What we don't have time to do, but what I consider quite important, there are criteria to select stations, which we have not gone into. So you can use names, like cruise names, to select only particular ones, but you can also use time of observation. If you want to just look at springtime data, you can use that. You can use availability. If you want to definitely do carbon parameter calculations, you only want to see stations that have alkalinity and total carbon and not see all the others, which for us would be useless. All these kind of selections can be done by using station selection criteria. So obviously that's something for the map. Right-click on the map, and here would be station criteria. Don't do it. We don't have time to do it, but I'm just telling you that's possible. Similarly, there are sample selection criteria. They actually let you filter out bad or questionable data. I haven't talked about this last column, which are quality flags. Each value has a quality flag, which you can set. And for instance, if you have outliers, you can give them a flag of being a bad data point. These sample selection criteria later allow you to not look at them. They are filtered out. But we don't have time to go into it. So what I wanted to get at is the derived variable thing. And you get this kind of dialog. On the left hand, you see the derived variables that you actually now have. And for instance, the section coordinate is a derived variable. It's obtained from the station. That's the only one that we have right now. Here in the list is the list of choices of what you can do. And there are many things, many physical oceanography things later in the exercises that you are supposed to do on your own. How much time do we have? 20 minutes. You may have to use potential density because we want to see some property on a density surface. In order to be able to do it, the first step is you have to have density values available. Typically, they are not measured, so they are not part of the data set. How do you get them? As a derived variable. Let me do it. So potential density, you choose it, and then you click on Add. You know that all these formulas, they need input. Density, for instance, needs pressure, temperature, salinity. How does the software know which variable is which? It will ask you. So here in this case, it doesn't know which of the variables is temperature. So it's a dialog prompting you, please identify temperature in degrees Celsius, because that's the units needed in the formula. It has tried, it has matched the labels, and it's suggesting it may be this one. But you have to confirm. In this case, you would just click OK. Now it knows temperature. It wants to know what is salinity. In this case, because CLODAP uses these cryptic names, there is no automatic way of matching. But you have to go there, say, oops, I was too quick. I double-clicked. Usually you select this one and then you say OK. You can also double-click and then it's selected.
I'm clicking one and clicking add and nothing's happening. But some of the others work.
You are doing what?
When I click on, say, CO2 and click add, nothing happens. But other variables, if I click on them, they do what you're saying.
Who? I'm getting to these parameters in a minute, and let's see whether you can reproduce or not. So with potential density, there's this additional reference pressure that you need to put in. So let's just take 0. So now we have a derived variable sigma 0. That will later be used for other things. But for the first time now, let us do some carbon parameters. Do you have a favorite one? We have the speciation, for instance, HCO3 minus. We have the fugacity of CO2. We have CO2 aqueous, or how do you call this? This one, CO3 3 minus minus, and several others. So you have to find them in this alphabetical list. Any preference what we should use? Omega aragonite. So that's one here. It also says, presently, all that ODV can do, it can calculate these things if you have DIC and alkalinity. Previously in this course, you have seen that even if you have other two parameters, you can calculate derived parameters. In ODV, maybe later, if people see a strong need for that. Right now, all these calculations require that measurements of DIC and alkalinity are present. So omega aragonite. Now, you being an expert on how to calculate these things, you know that temperature, salinity, and many things go into. Temperature and salinity, we just told the software where they are, so that will not be asked again. But what is total carbon? Which one is total carbon? That's still open, so we would choose this one and press OK. Alkalinity, total alkalinity, which in this case is this one.
So it's still not coming up with
When I pushed add, that window didn't come up.
Oh, yeah. Then somebody has defined this already. We get at this in a second, but let me finish that one. So now I've told it, you know that these equilibrium constants, they have a small effect on phosphate. So the program wants to know which one is phosphate. Also silicate, this one. Whenever one of these is not available, you click this one. Sometimes clicking not available is fatal. Like if you didn't have DIC and alkalinity, it just doesn't make sense, and this definition is aborted. But here in this case, this phosphate and silicate would make it survive. It would just use 0.
I made a mistake, and now when I do edit or delete, I cannot define it again. How do I do that?
Let me finish that one, and then we try to solve the problems. Okay. Those were all the identifications, just telling the formulas where to get the different input parameters from. Now, as you know from last week, calculating these things is an art. And you ask 20 people, they give you 20 different sets of equilibrium constants. But it seems like the carbon community now has come up with a recommendation which is in this book. Andrew Dixon, I think, he's the first author of it. He was here. He is one of the masterminds of ocean carbon research. It's our best knowledge of constants that we should use. And that's the default that ODV will use. But if you definitely want to use some older conventions, then choose these other constants. Okay, then sometimes you want to have these things in situ. What were those things in the water column where the sample has been done? So for instance, omega, the saturation level, that's relevant where you are. Because if a foraminifera is living there, the omega at in situ conditions, that is what matters. But sometimes people like to calculate these things at lab conditions, for instance. Then here for pressure, you would say sea surface pressure, for instance, and for temperature, you would enter your lab temperature. If that was 25, you put 25. If it was 20, you put what you want. But typically, I would say most of the time, probably you want the in situ conditions. So you choose all this. And that finally completes the definition. And you should try later, actually in the name later, you can tell what kind of conditions you have chosen. If you had chosen sea surface conditions, it would say P equal to 0, T, depending on what you have chosen. If you chose 25 degrees lab, then it would show T equal to 25. So there is an attempt to make it descriptive. So that's this one. What else would we want to do? Oh, now let's try to sort out the mistakes. And some people said they were not asked to identify variables. The reason is somebody else did it before. This kind of information is remembered silently, which is a good thing, except you did a wrong association. If at midnight and you are in a hurry and you are associating the wrong things, then the results will be terrible. And there has to be a way to check and to undo. How do we do that? So it's a property of this collection. So you go to this menu and go down to identify key variables. I call this key variables used for some calculations. Okay? You should get this kind of list where on the right-hand side, it's the list of variables in the collection. These are the CLODAP variables. And here's a list of all the key variables that I have defined so far. And whenever there is an asterisk here, then that one has been associated to some variable. If you want to find out which, choose it. It will go to the sister or brother. And in this case, that's a good association. If you want to know phosphate, where is it associated to, that looks good. If you want to redo it, no matter what the present status is, if you just find phosphate is associated to the wrong one, you would select it just like it is, and you press undo. I can do this now. So phosphate is no longer associated. So next time phosphate is needed in any calculation, it will ask you again. But if you don't trust these associations, maybe you're somebody you don't trust has done the old ones and you want to be sure it's done again, just click undo all. Okay. And now try to set up a derived variable again. Why not choose carbonate, add, and see it starts asking me again for all these things. And I would have to respond every time, which I don't want to do right now. So here I would say not available to total carbon, and that will abort the definition because it doesn't make sense to calculate carbonate ion if I don't have carbon. Okay, still with me? Then there is one final thing I have to tell you that has to do with the maps. If we want to display, for instance, omega on an isopycnal, let's make that our objective here. How do we do that? And now finally we get to this window here, which contains isosurface variable. It's a strange thing, but hopefully you will see in a minute what I mean by that. Right-click on this window. There's just one choice, isosurface variables, and you should get this dialog. Get it? Isosurface variables is the following. Here in the first place, you define a variable that you want to look at. So for instance, omega A. Okay? That's the first. This is what we want to see finally. And the remainder has to do where, on what kind of surface. And if you want to see it on a depth surface, like 200 meters, you would keep depth. And here you would say 200. Then, and I add it. This has now added an isosurface variable. What kind of variable? Omega A at a depth of 200 meters. And you could look at it. But let's define omega A on an isopycnal. So omega A, but now the variable that defines the surface has to be chosen differently. We have to use potential density. Fortunately, we have defined it a few minutes ago, sigma 0. And now we have to specify a value. Any favorite one? 27? 27. So you can add to this list of isosurface variables just as we have done, but you can also remove them. So if we want to remove the first one, you click it, you delete it. If you want to delete the next one, click it, delete it, and so on. So that's the way of requesting something on a certain surface. If you wanted to know at what depth the isopycnal was, maybe we now move over to getting more involvement from your side. What kind of isopycnal, what kind of isosurface variable should I define if I want to have a plot that shows me depth of that isopycnal? Well, I would choose depth because that's the one that I want to see. On what kind of surface? Well, on the surface sigma 0 being equal to 27. So that's the kind of way it goes. And it's quite flexible of what you can do, all kinds of things on all kinds of surfaces. And then you say, okay. Finally, how do we look at plots that show us these maps? We have to go away from these section plots. So we need a different layout of windows. Right-click on the canvas, layout templates. And then we choose, for instance, this one that will just have one large surface window. Again, this is a quite common request, so just pressing F12 would have given you that. And it will display the first isosurface variable after the 4 trivial ones. The first 4 are kind of trivial, and then it would use the first one by default. So if that's not what you wanted, what would you do? Mouse over this window, just pressing Z if we want to change the Z variable. You get the list of isosurface variables now, and why not have omega on this isopycnal? Okay, and here's omega. And this plot obviously shows that we are having a problem with one cruise, which fortunately I'm not responsible for. But the values that are obtained for all these cruises kind of sets the original range. And as you can see, it's way off. If we want to fix that, right-click on it. So we are already repeating things that you have learned before. So here in this case, I would go to Set Ranges. And what we want to change is the settings here for Z. And values below 0 are impossible. And let's try the range between 0 and 5, something like that. And now you start getting well, I was just about to say more reasonable values, but in this case, I really believe it's not a problem of the software and calculating these things, but it's kind of the tricky aspect of these parameters that require the highest quality DIC and alkalinity data to get meaningful things. But we are approaching 3 o'clock.
At what point do we switch from our section to that whole area?
I right-clicked on the canvas and I chose a layout template. And I was choosing one with one surface window.
So at that point you lose your section orientation and it goes to the...
You lose it only if you haven't saved it before.
No, but I meant as a selection in your view.
Yeah. You can only have one layout at a time. So when you make these radical changes, save the view before. I recommend, as a general rule, whenever you have clicked for a while and you think, oh, this I don't want to do again and again, then save the view. Give it good names so that tomorrow you remember these things. Let's quickly go through 2 steps. One would be maybe refining the color range. but it doesn't get better. The other one would be to make it a gridded field. So right-click on it, Properties, Gridded Field. And for this case, we definitely would need larger length scales because the holes are bigger as compared to the section. These length scales, it's kind of a subjective thing. If you have done it 5 times, you know how it's going. It's kind of fiddling around with them. I would use 50 here at least and 50 here and then do it. But obviously, we are having some problem with some of the data here, which there are ways to get at the bad data, but not for us today. We are approaching 3 o'clock, and now the question is, maybe I would respond to immediate questions that have piled up so far. Maybe that's the most productive thing. Do you have?
Yeah, I'm a little confused when you assign the isosurface variables. What is meant by first versus last? There's a pull-down menu for surface.
Well, first would mean the first sample. Take the first value that you have. Well, I should say the samples are all sorted. If we have profiles, they are sorted with depth.
Right, so that's just the surface.
First would mean in total carbon, take the first available total carbon value. That's sometimes it's a good idea, but sometimes not, because you don't know whether it's in 150 meters the first, or whether it's in 50 or so. If you have CTD data and you know that the first value is always 5 meters or 10 meters or so, first will give you a true surface. So first and last, be careful.
So then there's no choice in between. So if you've got, so last is literally the last sample expected on the CTD cast, so that's presumably close to the bottom.
Well, first and last is just picking samples. A normal isosurface variable, as I would say, they have some values. So let's take the depth example, like 200 meters, for instance. That's a good one because that defines a true surface.
Oh, so you don't need to do the full limit. You can actually manually enter in whatever depth you want.
Whatever. So you could have 3,000. You could have any. And in density, any value that makes sense in the density range. So you can actually have any kind of surface. If you don't want to use sigma 0, maybe you are working in the abyss. You define sigma 4000 and use a value for that one. Okay. What I had in the exercises to work on for you, the challenge was to use omega A to define the surface and to find the depth where omega A is equal to 1, which is kind of the equilibrium surface. So these kind of things are all covered by these isosurface variables. It's quite flexible. But I can warn you, I did it before looking at this one. It doesn't look as bad as this diagram, but with omega and all these carbon parameters, we are really talking about very sensitive things. And if the basis data, DIC and alkalinity, contain errors or inconsistencies, you run into trouble with those. So don't blame the software for all kinds of bad things. Some.
Can you make differences between, say, two plots? Like if you want to...
You can make differences. If you have sections, you can make differences between two realizations of the section. That would take us until 5 o'clock to do it. But it's possible.
There was a worse thread, say, in 19...
You can look at the difference. The basic steps are one of the two you define as reference, against which you want to compare, maybe the most recent one, and you save that there's an option to save this as a reference, and later you define the difference. Should I go into that? It's not something you do on your first day, but it's possible, and you can look at differences. And actually in global change research, this is what you like to do from time to time, look at differences. It's possible. But I should also say presently, it's not possible to do this in maps. Do we have other questions?
Can you again go over how you change the legend, the bar, the color bar?
To have a different color bar?
The values?
The range? So several ways, either by z-zooming, is that what you mean?
Right.
Or by set ranges and then specifying the values manually.
Thank you.
Yes? What do we do? If you're interested and we can meet, but officially we are right at the end here. But I'm happy to show it to anybody who wants to learn it. Where do we do such a thing? Do we have other questions that may be answered more quickly?
How do you change the size of the map?
The size.
Yes, you can arrange, rearrange.
Oops. Okay, it's an issue of the canvas. Right-click, window layout. We never used it. Now you are in layout mode. You can zoom again. Oops. Wait a minute. Move, resize. You get these familiar frames. You do it like this. You can also delete individual ones, create new ones. So that's the interactive way of making a non-standard layout. And you can do a lot. So there were some other questions up there.
My map doesn't have any background to it, like it doesn't have the...
That must be an installation problem which we would have to sort out on an individual basis. Yes, anybody who wants a sheet of these exercises, because we didn't have time to do it here, feel free to work on these exercises. If you want, you can even send me the images. I'm not sure whether I have time to look at it. So who needs this? Why don't you pass? So it's that area. Any other question?
How do you get back from the map screen to your other screen?
Oh, right-click. So the magic is right-click. Whenever you want to move, right-click. And then say accept. Any other question? So if there are no questions, unfortunately we didn't get at the point I wished we could, but if I have achieved that you get a feeling of what you can do with the software and you became curious, please keep on studying yourself. There's help. Maybe I should finally say where you find help. And many of the dialogues that you have seen, they have a help button which will get you context-sensitive help. Maybe not on the Macintosh. On the Macintosh, you have to find the right spot in the manual yourself. But on Windows, it will jump where you need it. So feel free to use it and use it for your research. And that's where I stop. Thanks. I'm all day, but tomorrow morning I have to leave.
I was going to suggest if people have questions, maybe you guys could meet after dinner
Yeah.
and
Yeah.
have like
Yeah.
individual. You could go
Yeah.
to the library or something. There's plenty of